record on this computer. All right, so what are LLMs? In simple terms, LLMs are statistical models which have been trained to recognize and predict text data using machine learning techniques. Like any sort of machine learning, LLMs are trained using existing text data to learn patterns and make predictions. They are very fancy prediction-making machines. What makes LLMs uniquely large is that they've been trained on literally millions and millions of data points, right? So as LLMs use text data, they've been given books from various genres and fields, articles from newspapers, magazines, and academic journals, websites, just the entire internet, social media posts and discussions, and code repositories and documentation in order to train their predictive models. Right? And they're also large in that they cost billions of dollars to create and train. But this vast amount of diverse data allows LLMs to develop a very broad understanding of language and knowledge across many domains. As a result, they can generate human-like text on almost any topic. They can understand and respond to very complex queries, unlike many other sort of like programs. And they can perform various language tasks like translation, summarization, and question answering. And they can adapt to different writing styles and tones. If you ever gotten mad at ChatGPT, been like, why are you doing this? And then it starts apologizing because it can sense sort of the anger in your tone. It is trained to recognize tones. And LLMs do all this through, like I mentioned, a form of machine learning, which uses these complex neural networks inspired by the human brain to identify patterns in data to make predictions about what text should come next. And it's constantly improving as more data is fed and techniques are refined. Unlike traditional computer programs, LLMs don't follow explicit rules. Instead, they learn to recognize patterns in language and use these patterns to generate responses. This makes them incredibly flexible and capable of handling a wide range of language-related tasks without being specifically programmed for each one. But how do they actually work? So, like I mentioned, LLMs use machine learning programs to analyze vast amounts of text data. Machine learning is a computational method where programs learn to identify data features without explicit programming. In other words, instead of telling the computer exactly what to look for, we give it lots of examples and let it figure out the patterns on its own. Specifically, LLMs use a form of machine learning called deep learning. Deep learning is where models self-train to recognize patterns using probability. It differs from other forms of machine learning in a few key ways, or some other forms of machine learning. So it uses neural networks, like I mentioned, when we'll talk about in the next slide. These are complex algorithms inspired by the human brain with many layers of interconnected neurons used to process and transmit information. It can handle unstructured data. While many machine learning methods need data to be carefully organized, deep learning can work directly with raw text. It really excels at finding very subtle patterns. So deep learning can discover intricate relationships in data that might be too complex for simpler machine learning methods or human programmers. And it improves with more data. Unlike some other methods that plateau, deep learning models often continue to get better as you feed them more and more information, although there is some debate as to whether our current deep learning models have much more room to improve. But in the context of LLMs, deep learning allows the model to analyze trillions of words and learn not just vocabulary, but complex language patterns, context, and even some semblance of meaning. This is why LLMs can generate such human-like text. They've learned the patterns of language at a very, very deep level. But this also means that while these models are incredibly sophisticated, they're essentially very advanced pattern recognition and repetition tools. They don't truly understand language as we do, but they're just really, really good at predicting what text should come next in any given context. This is why LLMs are sometimes derisively referred to as silicon parrots, because they are like very, very advanced parrots. They don't actually understand what you are telling them, and they don't understand what they are saying, even though it can seem like that a lot of times. It's just based on, this unimaginably large text corpus. They're very good at predicting what text should follow in a way that will make sense to us. Right, and this image here sort of illustrates how the LLMs are trained. Step one, you basically teach the model by showing it good examples. You give it good examples or examples of good answers. The model learns by copying these examples. And then step 2, you help the model understand what makes a good or bad answer. So the model gives different answers to the same question. Humans rank the answers from best to worst, and the model learns how to tell which answers are better. And then in step 3, you use rewards to make the model better. These are not like actual, like treats that you're giving the model. It's just basically a score, where a high score is a good reward, a low score is a negative reward. And the model tries answering new questions. It gets rewarded based on how good its answers are, and the model keeps improving based on these rewards. These are how all of these LLMs have been trained. Just an example of how one model predicts text. So if anyone here has used Claude, Claude is my personal favorite LLM to use. It just like is the best at writing of any of them. But I gave it this passage from the end of Dubliners. If anyone is a fan of James Joyce and Irish literature, very beautiful description here. And I gave it this ending passage here, and I just removed the name of the person. So, and it correctly identified that the blank in this passage should be filled with the name Michael Fury, and it correctly identified the short story. James Joyce gave me a bunch of context on who Michael Fury is. But how did it actually arrive at this answer? So basically, LLMs first analyze the LLM first analyzes the entire passage. It looks for context. It recognizes themes of snow, Ireland, burial in a churchyard, right? And then so based on its literary text, the LLM would probably recognize this as a literary passage, likely from a well-known work, based on pattern recognition. And then, if it has the specific passage from The Dead by James Joyce in its training data, then it can just directly draw from that. Even if it doesn't recognize the exact passage, the LLM understands that the blank likely requires a person's name, given the context of someone being buried. LLM would also consider the lyrical, sort of like somber tone of the passage, and predict a name that would fit the style. And then it calculates the probability of different names fitting this context based on its training data. And you would choose the name with the highest probability, in this case, Michael Fury. And it gives you the output, which was the correct answer of Michael Fury. But again, the LLM is not understanding the story in a human sense at all. It's making a statistical prediction based on patterns it's learned from its training data. If it was trained on a data set that included Dubliners, which I'm guessing it did, have a high chance of predicting correctly. If not, it would probably just give me an Irish name. But let's dive a bit deeper into neural networks. Right. So again, like I mentioned, neural networks are computational models inspired by the human brain, consisting of interconnected nodes that process and transmit information. But first, why would we even create algorithms that mirror the structure of a brain? Well, it may not always feel like it, but our brains are incredibly good at processing complex information, recognizing patterns, and adapting to new situations. These are exactly the kind of tasks that we want these advanced computational machine learning methods to perform. By mimicking the structure of the brain, we're trying to recreate its efficiency and flexibility in handling information. The brain has evolved over millions of years to process information in a way that's both powerful and energy efficient. And so we're trying to replicate that with our algorithms. But what are neural networks actually? So, like I mentioned, just as our brains are made up of interconnected neurons, artificial neural networks are composed of interconnected nodes, often called artificial neurons or simply units. These nodes are typically arranged in layers. We have an input layer that receives initial data, one or more hidden layers that processes the data, and an output layer that produces the final result. Each node is connected to nodes in the adjacent layers. These connections have associated weights, these parameters, that determine how much influence one node has on another. And information flows through the network, getting processed and transformed along the way. Each node takes in data, applies some sort of mathematical operation to it, and passes the result to the next layer. But when we train a neural network, what we're essentially doing is adjusting the connection weights that we mentioned earlier. Right? So the network learns by repeatedly processing data and adjusting its weights to minimize errors in its output. In the context of LLMs, neural networks are processing text data. This input might be a sequence of words, and the output could be a prediction of the next word, or a classification of the text sentiment, or any number of other language-related tasks. What makes LLMs special is the scale and complexity of the neural networks. They use a specific type of neural network called a transformer model. These models can have billions of parameters, throughout the weights, allowing them to capture incredibly nuanced patterns in languages. So transformer models came about in 2017. I think I'm right there. Correct me if I'm wrong about the origin, Scott. But they're essentially trained to handle sequential data like language incredibly well. The key innovation here is something called self-attention. So basically, transformer models are trying to capture context in a way that mimics how humans understand context. So in language, obviously, context is really crucial. The meaning of a word often depends on the words around it. Transformer models are meant to capture this context. It does this by parallel processing words within a given text. So it doesn't process text word by word. Instead, these transformer models look at entire sequences of words all at once. This makes them much faster and more efficient than other neural network models. And the model can pay attention to different parts of the input when producing each part of the output. It's like how we might focus on different parts of a sentence to understand its overall meaning. The transformers can easily connect information from the beginning of a long piece of text to information at the end. This was a major challenge for previous models. In practice, this means that transformer-based LLMs can understand nuances in language, handle complex queries, and generate coherent, context-appropriate responses. For example, if you gave an LLM the sentence, or I should say a transformer model, the sentence, "The animal didn't cross the road because it was too wide," the transformer model, like a human, is going to understand that it in this sentence refers to the road, not the animal. This kind of contextual understanding is what makes LLMs seem so intelligent in their responses. Let's see, any questions so far? Sorry, I know that was a lot. Cool. All right, but what are LLMs actually used for? Well, of course, generative AI, text generation is probably the most well-known use. It can generate human-like text sort of incredibly rapidly and, up to growing number, like probably 1,000 plus like characters now, I'm sure more at a time, or thousands, I should say. It can generate essays, stories, poems, scripts. It can also generate code. I'm sure many of us have used it to generate code. It can do R, it can do Python, it can do Java. I'm sure it can do any code that it's trained on, obviously. They're trained on programming languages and they can assist in writing code or completing partial programs. Very good for helping you troubleshoot things. They can do sentiment analysis. So, they can analyze text and determine the emotional tone behind it. What else? Oh, yes, chatbots. So if you give the LLM particular data that you're interested in, or if you sort of give it particular inputs, you can use it as a specific chatbot. So some instructors are like Neil have created chatbots for their classes where you give an LLM your syllabus, you give it all your material for the class, and then it can essentially act as like a resource for students who can ask it questions, ask it about due dates, ask for clarifications about concepts in a way that is specific to a particular context. Then also online searching. Some LLMs like ChatGPT are now connected to the internet and can do online searches for you. I didn't mention it here, but some LLMs can also do data analysis directly within their software. So like ChatGPT can do data analysis, hit or miss in my experience. But we'll talk about that in a little bit. And just some examples of LLMs. Claude, like I said, my personal favorite. ChatGPT, the most famous one. Copilot, it's the one that the university pays for us. And then Bing Chat. But what are the strengths of LLMs? What makes them so powerful? Well, their main strength lies in their flexibility and ability to handle unpredictable inputs, right? So unlike traditional computer programs that need specific commands, LLMs can respond to natural language queries. They can take an unstructured question like, what are the 4 greatest funk bands in history, and provide a reasoned response, even if they weren't explicitly programmed with that information, which is very, very impressive. But of course, LLMs also have limitations. So LLMs are only as good as the data they're trained on. the training data is biased or inaccurate, the LLM's outputs are going to reflect those issues. Hallucinations, infamously, an LLM, if an LLM does not know the answer, or even if it does know the answer, it might generate plausible sounding but entirely false information. You know, an issue for our students when they use LLMs to do their homework. Also, like I mentioned, just lacks true understanding. Like the LLMs don't actually know what is going on. They are very, very fancy parrots. Also, you have to watch out for security and privacy concerns. So LLMs can expose, potentially sensitive information as part of their training data. Also, we don't really know much about how they're being stored. There's not much regulation in their usage and what the data that they're taking from our inputs is. And there's various ethical concerns about privacy, the environmental impacts of LLMs, whether they can be manipulated, produce biased or harmful content. There's sort of been mixed results here. They have lots of safeguards within most mainstream LLMs to prevent ethical misuse, but they still can occur. And most importantly, like these are very powerful, very cool tools, but they're not infallible. They're best used as aids to human intelligence rather than replacements for our own critical thinking and domain expertise. All right, so that's sort of the first section. Any questions?
Hey Jacob, I do actually have a question.
Mm-hmm.
So, can you talk a little bit more about like the training data, like where, I guess like where to, like what are there any like common data sets that people use to train the model, or like what are also like if you could talk a little bit about like language issues, right? Like other than if I want to analyze some text that are not in English, right? What are some like other what are some like training data sets that are available out there?
Yeah, those are both
It,
really good questions. Oh, sorry. Sorry for interrupting.
oh no, Jake, does my question make sense?
Yeah, yeah, yeah.
Okay.
For the first one, I will say, in terms of the commercial LLMs, we don't know much about their training data because it's sort of, we know that it's just an immense and unimaginable amount of data that they've used to form the basis of these models. Anything that they could get their hands on, like they've said they spent billions and billions of dollars training, like ChatGPT, and I would assume it's basically the entire internet was used to train the models. And as for like your own personal, oh, interesting. I just saw Amanda's message in the chat. As for your own, like if you wanted to make a personal sort of like set of training data, you could use so you could use ChatGPT as like a base sort of model. Like it has its training data already there, and then you can, like I mentioned, do something like make a chat bot with it. So you can give it your syllabus, you can give it all your readings for your class, all your writing guidelines, and you can use that to it will use that new training data to then fulfill specific functions as you design it. I've never designed a chatbot. Neil would be the best person to like ask about how to incorporate specific training data. But yeah, I don't know of how people might use. I haven't seen anything about people like using common training data sets. As for your second question, I do know that there are LLMs that have that can be used in multiple languages. I don't know how the training data reflects like I don't know if they are trained only on like English data, for instance, and then just sort of like translating it into another language, or if they have a different training data set in that language. My guess is that they would have to have a different training set in that language because they have to, be able to create like a realistic, like reflection of like syntax and like, conversational style. But I am less familiar with how LLMs might use, or how LLMs in non-English contexts might work. Sorry, do those answer your questions?
Yeah, thank you, Jacob. That's great.
Okay, Scott is going to jump in.
Yeah, no, just the question thing, or the question about different languages. I know that there's a Chinese LLM that's trained entirely on Chinese language content. I don't know how exactly it performs. I think I was talking to some people in Hong Kong about it when I was there, and I think it might be state sponsored, and they're trying to compete with some of Google's LLMs. But as far as I know, it's entirely based on Chinese language content and intended for that use. I don't know about other language initiatives, but there are definitely some non-English LLMs out there.
And I did just maybe want to jump in quickly on maybe a clarifying point. If you were to use an LLM, like you definitely like would not be training your own LLM. Like you're going to use one of the off-the-shelf ones developed by these companies and then kind of tweaking it for your own, unless you have like millions of dollars and are going to build your own model. But that was definitely something that like when I was first getting into this, that was a little bit confusing. So yeah, just wanted to like, you will not have to seek out training data. The idea would be to use something that's already trained.
Yes, that's important clarification. Thanks, Jenna. Unless, like you mentioned, you have millions of dollars to spare and a lot of time and coding expertise, then you could train your own LLM on whatever specific use case you have. Any other questions?
Just a quick comment that you can certainly augment the model by supply it with lots of your own data and tell
Yeah.
Yeah.
Oh, sorry, I interrupted.
No, yeah, I'm done.
But yeah, no, definitely. Like, if you give, ChatGPT a particular document, like it's going to focus on that document when answering questions. Like it's not going to, or it is going to draw from its training data a little bit. But if you ask it like what is the definition of like this word, and it was like defined in the document somewhere, it's going to rely on the text you give it more so, or it's going to prioritize the text you give it. All right. Well, so core of today, using LLMs in social science research. Oh, wait, sorry, the chat question. Trying to train your own little GPT is, oh, that's cool. All right. Well, if you want to train your own GPT, there you go. Has anyone here used LLMs in their research before in any capacity?
Yeah, we for like data repository stuff, the Dataverse infrastructure, there's an implementation at UNC. We've managed to layer on an LLM on top of the repository, so you can ask questions like, if I was interested in data on North Carolina historically climate something, what data sets would you recommend? And like spits out recommended data sets. So it's been really cool as like an interface between technical stuff. Other than programming, that's the only fun use case I've seen for myself.
Yeah, no, that is a really cool use case. Yeah, like essentially, like you said, wait, what did you layer it over again? Was it the?
So it's like a whole structured repository of research data that we've like collated and dumped a bunch of research data into a repository, layered an LLM on top of it so that people without technical skills can figure out how to access publicly available data sets and understand all of the metadata without diving into documentation.
Yeah, no, and that's a really great example of like one of the main advantages of LLMs is that they, raise the floor of like, various skills. So if you don't have the, technical know-how for how to like navigate, like mention like these repositories or like how to understand the information, like they can, LLMs can personalize outputs, explain things, walk you through things as best they can, and oftentimes it is surprisingly, effective and accurate. You said you mentioned you used it for coding, which is another big one, obviously. Yeah, automates coding, especially like very simple coding tasks very well. Yeah, I feel like I need to like refresh myself on like the core of R. Again, too reliant on LLMs.
I have to work in this secure research workspace for UNC, and it has no internet, and I'm so bad at programming because I became so reliant on GPTs that now I have no idea how to code anymore. Quite terrible downside.
Yeah, it makes things too easy. So,
But you
Hey,
can
ChatGPT.
install
Oh,
your
sorry.
own GP or Llama onto a local machine, and that does not require internet. And you can, it can download a coder, and you can do all kinds, all kinds of stuff with it.
Oh, interesting. If you want an R refresher. Very much. I use ChatGPT to generate pseudonyms from interviewees based on their org. Yes, so very simple task that would like take you a while. Like, yeah, it can very quickly automate them. But yeah, so LLM applications in the research pipeline, very basic stuff. Brainstorming ideas. One's relatively straightforward. You can use LLMs with internet connections to, directly search for articles. You can ask it to, suggest novel research questions based on existing literature, identify potential gaps in current research, propose unexpected connections between different fields or concepts, help researchers, think outside the box by offering, a different perspective. Data preparation and visualization. It can suggest relevant variables to include in your data set, can help to clean and standardize data by identifying inconsistencies or outliers, assist in creating code books, can generate data for you. Also can really just make your coding like way more efficient. And again, or summarizing text, this is I think one of the key, this is what LLMs are best at. They excel at summarizing large volumes of text, which can be incredibly useful for quickly, digesting research papers, summarizing key findings, creating literature reviews, extracting main themes from qualitative data. And then it can help with writing. You can provide feedback on writing quality and clarity. Partially by asking it to just interpret your work. So you can be like, you can give it a passage you wrote and then see if it is capturing your main argument. It can generate outlines very quickly. It can suggest ways to rephrase complex ideas. It can help you just organize your thoughts. Then you can use it to conduct preliminary analyses, suggest appropriate statistical tests based on your research questions and data, help explain the statistical concepts to you in simple terms if you're not like a statistician. It can help to interpret initial results and suggest follow-up analyses, help you generate hypotheses based on your preliminary data patterns. You can do a lot. Yeah. For example, so let's see if I stop the share for a second. Share. There's ChatGPT. Here it is. Share. So I bought ChatGPT Plus for this to make it so that I don't run out of data analysis uses. But for instance, let's see, upload from computer, desktop, LLM Workshop. Well, one, I had it generate a bunch of fake interview data on answering the question, are you a dog or a cat person? So, let's ask it some questions about the interview data. What should we ask it? What could it summarize, I guess, summarize the responses in this text data to the question, are you a dog or cat person? It's not the best prompt. Chat. Dog people appreciate the loyalty, energy, playfulness, and the way dogs encourage outdoor activities, provide emotional support. Many mention how dogs became part of their family and how their enthusiasm is uplifting. Cat people admire the independence, low maintenance, nature, grace, and calming presence of cats. They also appreciate how cats match their quiet or low energy lifestyles, some resonating with the mysterious and subtle ways cats show affection. Few respondents love both animals equally, appreciate the unique qualities of each. Others express neutrality, one person mentioning being allergic to both. I think that is true. I think it came up with this data by itself. But again, very quickly summarizing this text data interview data for you, help you identify patterns. Here's an example of a paper from Scott published in ASR this year. We'll see if this is correct. All right, what should I ask it, Scott, about this your most recent ASR publication?
Ask it if the author is a dog or a cat person.
Is the author a dog or, we'll see, or a car person or a cat person? It will probably tell me that there's no way to know. Document you shared doesn't provide personal insights about whether the author is a dog or cat person. Darn. The text focuses on academic research analysis regarding political elite polarization and crime policy collaboration. Is that correct? Nothing about your dog in there?
Yeah, ask what the paper found.
All right. What are the findings of the paper? So the findings of the paper focus on how network structures shape legislative collaboration and crime control bills in the context of elite polarization. The study finds that network assurances such as prior co-sponsorship and reciprocity become increasingly important as elite polarization rises. Study shows that while elite polarization suppresses legislators' response to crime rates and public fear of crime, network structures help to mitigate some of the risks involved in collaboration on controversial crime policies. Research highlights that while networks promote collaboration in the short term, they also contribute to greater political polarization in the long run. The study also identifies differences between Democrats and Republicans in their legislative behavior. The Democrats were more responsive to crime rates, particularly through bottom-up pathways. Republicans' actions were more influenced by electoral opportunities, aligning with law and order politics rather than actual crime increases. Is that all correct?
About 90%, yeah.
90%? Okay, that's pretty good. I'll take it. I'll make sure to tell it that you're a dog person.
I'm gonna
At least
start thanking Parker in all my papers.
You should. And if one day somebody creates a Scott, bot.
I have a
Oh,
quick
no.
question on like maybe thinking like where to use these large language models and like research like the work in our own workflow.
Sure.
I guess like I know one thing that people do with these models is to create their own personal assistants, and that is different from what I think Jenna mentioned at the beginning, in which you need millions of dollars in order to like create your own big large language models. In case folks don't know, by these assistants that Abhi mentioned, it's basically like, well, I don't fully know because I've never created a personal assistant, but having a very specific use case, like what Neil used with creating a chatbot, personal chatbot for students. But I guess I'm wondering like how much work does it take to create your own personal chatbot versus using a chatbot that someone else created? Because I noticed that like using a assistant that someone else created, because I don't know if like assistants will be like shareable, for instance, like maybe someone already out there has created a uh personal lit review Zotero assistant or something like that. I could see a lot of us putting in the work now to create our own like personal assistant on these large language models, and maybe ask it to access our folders or our many readings on Zotero, but I imagine other people out there have already done that. And I guess what I'm wondering, well, I don't really have I guess my question is kind of like, are there repositories of these personal assistants and useful use cases out there, like that we could just find? Because I think it's a lot of work if it is a lot of work to create your own personal assistant for a specific purpose, I wonder how much it's worth it. I don't know.
Yeah, no, that's a good question. I have never created a personal assistant and I've never used any of the custom ones. Young seemed like he may have. I mean, based on what he was saying, so maybe he could provide more insight into like how hard it would be. But I know that like for Chat GPT, there's like if you explore GPTs right there, right here, you can search. So like Zotero, I don't know. We'll see if Zotero Assistant, 3.9 stars. Basically, it has its own like app store for custom GPTs that you can download and you can try and use, so let's see, academic research notes. This one has 4.5 stars. Upload a research paper and get a highly formatted full APA 7 notes created for your reference collection. Seems pretty good. Yeah, and there's lots to explore there. Sorry, what, Yang, you're gonna step in.
Yeah, so creating a personal assistant is not that difficult, but you do have to have a reasonably fast enough computer. So I use Olama, and on my old computer, the one I'm using right at this moment, I basically took a very small model. Relatively speaking, it's only 0.5 billion parameter model. And that's good enough to do all kinds of basic stuff. For example, check spelling or summarize a page. Those things are good enough. And if you want to do more sophisticated, say, hey, I'm going to feed it with like, 100, let's say our comp exam reading list, and say, summarize all those papers for me and try to write, potential exam questions. That will require some kind of tweaking, and it's not like a hit and you can go thing. It takes time to basically, for example, you feed it with the reading list, you feed it with the questions, and say, and going back and forth, and it requires quite a bit of computational power to do that, and it takes time.
Thank you for the insights, Yang.
Yeah.
Did that answer
I have a
all of your question, Todd? Oh, sorry, Justin.
I have a clarification question.
Sure.
Does anyone know off the top of their head what the scale what the scale is as you add personal documents to your GPT? Like, can it scale to 3,000 PDFs for a personal implementation? I thought the answer was no. But Todd's question made me like rethink, like maybe that's changed, or maybe I'm wrong.
So the latest information, I have not looked into, because all those things require some high resource. For a while, Google was providing access to its Gemini model up to, I think, a total to 2 million tokens. And so that translated into quite, a hefty, at least a couple of books length of the material you can feed it into. And if you do, you have enough hardware, you can, it's the physical limit is your hardware.
Maybe this is related, but I know that Matt Brunig, if anyone knows him, interesting writer, lawyer, but he's used Google Gemini to make his own like database of labor law cases. Like, he has basically given it like all of the labor law cases that he can find, and then it summarizes them, organizes them, and like lets you peruse them in a way that's very like, simple, organized. Like, what did this case decide? What prior cases did it rely on? And I know that he's also tested it with like multiple LLMs to make sure that the summaries are accurate. And that Google Gemini like kept shutting him down because it like, you reach your limit, and then he would just be like, no, I didn't, that's a mistake. And then they would just let him keep doing it. So maybe the limits are easily surpassable.
But you can always pay if you have the money.
Yes, I know Braxton's very anti P, but he's an interesting guy. And yes, you can always pay money. One last demonstration of just like the capabilities of LLMs, then we'll get into real quick. I know we've already gone over, so if you have to go, no worries. We'll get into some interesting novel avenues. But so it created this social media use data set for me, and I'm going to ask it visualize this data set as a bar graph tracking social media platform use by gender. Bar graph is not one word. So it just made this, originally it made a very detailed one with like fake interview quotes. And then I was like, yeah, it can be more simple than that. And it can very quickly visualize your data for you. You know, it'll actually provide you the code that it used to do it as well. If you want to make sure that it's doing it correctly, its default is Python. You can ask it to code in R as well. So if I said, can you provide the code to do this in R? It'll give you the R code, it'll give you the necessary libraries. It'll give you like, you know, you have to fill this in with your own path, obviously, to the data set. But it can very quickly allow you to visualize data. All right, now on to some of the cooler uses. Not that those uses are not cool, but back to the LLM workshop here. Sure. All right, can you all see the PowerPoint? Yeah, okay, cool. So incorporating LLMs into research design. Oh shoot, I left image analysis in there. Analysis, I did not have enough time to dive as deeply into image analysis as I would like, but you can ask Neil about how to use LLMs to analyze, for instance, images of protests. But so these are some interesting use cases I found for how LLMs can provide new creative ways of engaging in or doing social science research. So first, modeling human behavior. Oh gosh, go back. This is from Aher, Ariaga, and Kalai, 2022. This was a very interesting study. Basically, the researchers wanted to know whether LLMs will simulate human behavior in experimental settings. They tested various LLMs, including different versions of GPT, on 4 classic experiments: the ultimatum game, garden path sentences, the Milgram shock experiment, and wisdom of crowds. And there's also really, really interesting. So in many cases, the LLMs replicated the human behavior patterns with surprising accuracy. So, you know, we see here in this chart, the Milgram experiment, which, if you're not familiar with it, is like the infamous, like, unethical psychological experiment about like you have a respondent come in and there's another person on like the other side of like a wall or something, and you're told that if they get a question wrong, you have to shock them. And then they're increasingly applying greater and greater shocks, and it's basically to test, you know, obedience to authority, but you're not actually shocking anyone, is the trick. And they found that language models do like match like human willingness to shock other people pretty well, although they seem, I guess, more willing to shock people than humans. So watch out for that. But a very, very interesting, like, you know, directly where humans start to stop shocking people, you see the exact same decline. They even replicated gender differences in human studies, basically by telling LLMs not that they were supposed to act as a certain gender, but saying your name for this is Mr. or Miss or Mrs. And they found that it replicated gender differences in the ultimatum game, which is basically like you are given, like, somebody has given you a particular amount of like money between $0 and $10. You get to keep whatever amount they have decided to give you, or you can just reject it and neither of you get any money. And they found that people tend to not like accept small amounts. So they would rather that just everyone gets nothing if they don't get you know, like what is perceived to be fair. They found that it mirrored human decision making very, very closely there. Same with the garden path sentences. That was basically like they gave sort of strange, grammatically tricky sentences, grammatically correct but difficult to parse sentences on first reading. So, for instance, "the old man the boat" is a grammatically correct sentence. But your first instinct is that it is not. "The old man the boat." People often misinterpret these sentences, and they found that these LLMs misinterpret the sentences in the same way that humans do. The one where it does not did not match human cognition is the wisdom of crowds experiment. Basically, aggregate judgments of groups we found are often more accurate than individual expert opinions, but they found that the LLMs were way too accurate because of their training data. But this is pretty interesting. Like, it allows researchers to simulate large-scale experiments with diverse participant pools. Can overcome some limitations of traditional human subject research. You could use models to explore scenarios that would be unethical or impractical to test with human subjects. It could help you generate new hypotheses, refine experimental designs before conducting studies with human participants. It reflects the importance of like the training data on LLMs. Like, the biases that humans have seem to be present in LLMs as we've measured through these sort of psychological experiments. And it can help us refine LLMs by making them, either more human-like or more accurate, which I guess in this case, they would have to be less accurate to be more human-like. Second use case, simulating social relationships, which I really liked because in the study they used the graphics from the third generation of the Pokemon games to simulate agents. But basically, researchers created multiple LLM agents, each with their own characteristics, backgrounds, and goals. These agents then interacted with each other and their environment. They made decisions and generated dialogue based on their programming and the capabilities of the underlying language model. This can help us reveal biases present in the AI's training data, can help us test social theories in sort of like a fancier agent-based model way. If you were here last semester, did agent-based models, and can, we might be able to do large-scale experiments in the controlled environments this way, test hypotheses that would be impractical or again unethical to test in the real world. Another interesting use case, interviewing, interacting with human agents. So Chopra and Holland used LLMs to conduct semi-structured interviews. The interviewers were, or the AI interviewers were prompted to, one, memorize what had already occurred in the conversation. Makes it so they can refer back to other previous parts of the conversation like a human. They introduced new topics from the interview plan. I'm trying to remember what this was. Oh, it allowed them to ask different questions based on topics that had not been broached by the person they were interviewing yet, but follow like a set, series of topics. They were formulated to ask follow-up questions based on the interviewee's responses. They could ask for clarification on ambiguous statements, on just general points. They would ask for more nuance, just as any like human interviewer might. And they would also, make sure that the AI would make the conversation stay on topic and flag any inappropriate responses. And so the AI is given this interview plan with broad topics to cover, but it has the flexibility to explore interesting avenues. And interestingly, a small majority of the respondents, I misspelled indicated a preference for an AI interviewer over a human interviewer after doing these interviews. But again, they managed to conduct 395 in-depth interviews, which, if you're a qualitative researcher, is crazy. And then finally, text annotation. So basically, for this one, oh gosh, I forgot to add a sorry, I'm now noticing my mistakes in the PowerPoint. Basically, they were trying to analyze sort of like topic modeling, trying to have LLMs do like a topic modeling, like text annotation style experiment here. This example of Leak, Bishel, and Fair, they used ChatGPT to analyze central bank communications. So they had 2 million sentences from speeches given by officials from 118 central banks, covered a period from 1997 to 2023. And they had ChatGPT code it. They wanted to create indices of monetary, fiscal, and financial policy linkages. In other words, they wanted to understand how central banks talk about the relationships between monetary policy, which they control, fiscal policy controlled by the government, and financial markets. Specifically, they trained ChatGPT to identify instances of what they call policy dominance and coordination. Policy dominance refers to situations where one policy area takes precedence over others. And again, they also look for instances of coordination where the central bank discusses working together with fiscal authorities or financial market participants to achieve common goals. What was really impressive about the study is like the level of conceptual complexity that the LLMs were able to tackle. They weren't asking it to look for specific words or phrases. They were asking it to understand and categorize complex policy stances. And they were able to do it at this immense scale. Again, 2 million sentences, something that human researchers, human coders would never be able to get through in a reasonable amount of time. And they found that like it was able to, with their guidance and checking with like training data, code it very, very like accurately. Also, like the LLM is going to be way more consistent than human coders. Ideally, if you're get tired or like you're reading like your 20th thing that you're supposed to be coding, by the end it might change based on your mood or something. The LLM theoretically should be just consistent and have the same criteria across all text. All right, that is everything I have. Appreciate you sticking with me for this longer than usual presentation. Throw us tomatoes.
Thank you, Jacob. I think this was a really, really fantastic introduction to LLM.